Shall we begin now? On your way out, I'm going to leave the sign-in sheet right here. So when you finish, just sign in or whatever. Let's start. Maybe we got that knife. Okay, let's pay attention. First, I do appreciate you coming on a Saturday on such short notice. I hope you'll find it beneficial. We're going to go over a lot of word problems that rely heavily on factoring. First of all, let's remember a little bit what is factoring. Factoring is when you take a combination of terms to transform it into a product of what? A classical example, 2x squared plus 4x to the third power. When we say combination, we know it's only addition or what? Only addition or what?
Multiply.
Subtraction. And definitely here we have two terms, 2x squared and 4x to the third power. We need to factor out those two terms. Well, it looks like we can factor out the GCF, right? What's the GCF here that we can factor out? It will be what? Well, between 2 and 4, we can certainly factor out 2, right? Between x squared and x cubed, what can we factor out? X squared. Well, 2x squared times what? What is left from the first factor then? Only what? 1. And what is left from the second factor, from the second term? Only what? Only 2 what? 2x. Remember, now we have a product of what? Factors. And how do we know that? Because this is 2x squared. This is 2 is a factor, x squared is a factor that is repeated, which is x. And the last one is 1 plus 2x. The terms are always separated by plus or what? Minus. While the factors are separated usually by what? By parentheses. Or by writing the actual numbers and letters, variables, just next to each other, right? So for example, this is a factor by itself. This is also a factor. How do we know they are joined by multiplication? Because you don't see anything in between, right? And the parentheses make sure that we isolate this and we treat the 1 plus 2x as an independent factor by itself. That is the process of factoring. Well, I mean, even if you are in a 305 or 306, you notice how we hand you the same handout when it comes to the strategies of factoring, because they are not different. First, you have a universal mandatory obligation. Always you have to check for the what? GCF. For the GCF. If you can find a common factor, you go ahead and find the greatest common factor and factor it out. If not, then you skip and you ask yourself some questions, right? If we have 4 terms, what do we do in this case? We use the strategy of what? Grouping, where we group the terms 2 at a time. It doesn't really matter which 2 you choose, in the hope that we can establish something of a common what? Factor. If you have 3 terms, mainly we are talking about a quadratic trinomial. If the leading coefficient is 1, we directly use the sum and the what? And if the leading coefficient is greater than 1, we use the AC what? Method, which is basically the same as the sum and the product, but a little bit what? Modified, right? And if we have 2 terms, basically we talk about investigating those 2 terms as special kind of what? Formulas. Now, what we want to do in this seminar, what we are trying to do, is show you some of the word problems and the applications that involve and rely on what? Factoring. Okay? Now, let's just confess right now and say the following. This is just a sample of problems. We can have more applications of factoring. But this sample is pretty good, pretty varied. If you look at the handout that I gave you, that handout comes from the Henry Ford Community College Math Lab. which is an excellent college, by the way. It tackles some of those problems. Some of the examples are worked out examples step by step. We will go over them, and you have plenty to practice. So let's first start with number problems. Usually when you talk about a number of problems, they will ask you to find some numbers are under certain conditions, right? Now, you and I know how to solve word problems, or the strategies for solving word problem, which is VESA, right? Can anybody tell me what VESA stands for, or what V and E and S and A stand for? V is for what? Choosing the what?
The variable.
The variable. And E is for setting up your what?
Equation.
And S is for actually doing what?
Solving.
And A for checking your what?
Answer.
And universally speaking, that is a pretty good way to go about categorizing word problems. So for the V, we still want to choose a variable, right? That does not change. Even in college algebra, does not change. You want to choose a very efficient variable, one that can help you reduce the difficulty of the problem. E is just setting up your what?
Equation.
Setting up your equation. And then S is what? Solving, right? And A is what? Checking your what? Your answer. This is what we're going to be using. This does not change if we are talking about problems such as distance equal rate times time, or if we are talking about problems such as mixture, or if we are talking about factoring problems. The general strategy is the same thing, but what changes is the type of the problem. Now let's pay attention. Let's remind ourselves of something. What is the most difficult step in all this? What's the step that is the most challenging step? Set up your what? Now that's not going to change. Why? Because that step requires all of you to be efficient what? Translators. Translators that know how to convert sentences from English to what? Mathematics. And you see, right now, in the first problem, I'm going to call on you, and I'm going to ask you to translate something. In the first problem, which is about the numbers, is example 1 in your handout. Would somebody read to me what example 1 asks you to do?
The sum of a number and its reciprocal.
The sum of a number and its reciprocal is what?
13 over 6.
Okay, so what I'm going to do actually, I'm going to copy exactly that same statement verbatim, okay? And then we see how we're going to do this. Well, the sum of a what?
Of a number.
Of a number. And then what?
And its reciprocal.
And it's what?
Reciprocal.
Reciprocal. Is what?
13 over 6.
13 over 6. Then what is the question? Find the what? Find the number and it's what?
Reciprocal.
Okay. Let us test our vocabulary. Let's say the number that I find is 4 over 5. Then what is the reciprocal of that number?
5 over 4.
5 over what?
4.
5 over 4. That's great. At least we know what the reciprocal is, right? That's good. Then we want to try to avoid words like flipping and stuff because they have no meaning in mathematics. They really don't. Reciprocals also referred to sometimes as the inverse for your knowledge. What about if the number was like this, for example, 4? Then what would the reciprocal be? 1 over 4. That's because you know that 4 is 4 over 1 and the reciprocal is 1 over what? 4. That's just good observation. Okay, well, what am I going to do to choose a variable? What am I going to do? Let what? I'm looking for that number, right?
Mm-hmm.
Well,
X be the number.
let X equal the number that we are searching for, we're looking for, right? Mm-hmm. I need to do some translation, don't I? If X is the number I'm looking for, what is the reciprocal of X? You kind of told me this, Michael, right?
Yeah.
What's the reciprocal of x?
1 over x.
1 over what?
X.
1 over x. That is the what?
Reciprocal.
The reciprocal. Now, notice from the very beginning here that those type of problems are not very difficult to set up, right? They don't require a lot of organizing like the distance, rate, and time, like those chemical mixture problems. They are pretty straightforward when it comes to setting up the problem, right? The number is x, the reciprocal is 1 over x. We are done setting up for the variable. Now, we have to do some translation, right? I need to set up an equation. Well, what kind of an equation I'm going to set up? I need to translate this. The sum of the number and the reciprocal is what? 13 over what? Then how would I translate this from English to algebra? How would I write now? What would I do? How would you suggest we translate this? What would we say? If we try and translate.
The sum of x and 1 over x.
So how do I do? What do I do in algebra? The sum means addition, right?
Yeah.
First I start with x, right? Plus what?
1 over x.
1 over x equal to what?
13 over 6.
13 over what?
6.
6. Well, that seems like a pretty reasonable equation to set up, right? Now pay attention. You did choose your variable. That's okay. You did set up your equation. Now it's time for us to talk about what? Solving. Now pay attention. All of you pay attention. You see, factoring is not involved in doing what? In choosing the variable, is it? So far we have not talked about what? Factoring. Also, factoring is not involved in setting up your what? Equation. Let us see if factoring is involved in what?
Solving.
In solving. Let's write it down, then you and I will talk about the solving. Take a moment to write down the equation, at least the setup of the equation. Up to here. And notice, ladies and gentlemen, that you have all the solutions here, right? So you really don't have to be detailed in writing, or it's just that this equation, that is my interest right now. That is what we're going to try to do, okay? And if you are in 0305, you're going to benefit greatly, because those problems, I mean, you're going to see the same problem basically in 0306. The only difference between factoring as it presented in 0305 or 0306 is that in 0306, we keep going and we talk about solving by completing the square and solving using the quadratic formula. But in 0305, I give the same handout, almost the same problems. The only thing that's different is those two extensions of the constant. Shall we erase all this? Well, I think that's why we have the eraser, right? Okay. Let's go. Let's see this equation x plus 1 over x equals 13 over 6, right? What's the problem with this equation? What's the denominator here?
X.
What's the denominator here?
6.
And what is the denominator here?
1.
1. I can't add fraction unless I have the same what? Okay. Let me ask you a question. You have heard of the term clearing out the fraction, right? Although I don't like it, but let's say we want to clear out. What is a number that I can choose that will get rid of x? Divided by x. How do we get rid of division by x? How do we undo the division?
By multiplication.
Multiply every term by what? Let's go ahead and do that and see what happens. So if I multiply here by x, and if I multiply here by x, and if I also multiply here by x, because this is an equation, right? We can't do something to the left side without doing the same thing to the what? So what will happen if I do that? Well, x times x will be x what? X what? Okay. Plus, notice here you have x and you have x, right? We are done. So what is left? What is left? Equal 13x divided by what? 6. Well, I did get rid of x. Now what do I need to get rid of? How do I get rid of the 6? Multiply every term again by what? By 6. Okay? Seems reasonable. Let's do it. Multiply here by 6. Multiply here also by 6. And multiply the right side of the equality by 6. What happened now? Well, 6x squared plus 1 times 6, which is 6. This cancels out, equal to 13 what? 13x. Okay, so what do I have now? 6x squared plus 6 equal to 13 what? X. Let's pay attention. This looks like a quadratic equation, doesn't it? Okay. Well, we are talking about factoring, right? If I were to solve this by factoring, if I were to try to solve, let's say, I want to try to solve by what? By factoring. What would I do if I wanted to solve it by factoring? Is this ready to be solved by factoring? What would I do then? Move what?
Oh no,
13x to the what?
to the left, then it equals
Because
0.
one of the fundamental requirements when we try to solve by factoring is that the right side has to be what? 0. If it's not 0, we are not ready. Remember, when you solve by factoring, the left side is equal always to what? 0. So we can use the 0 product what? Property, right? Well, for that to happen, I kind of need to move 13x where?
To the left.
To the left. And I want to place it in the middle, right?
Right.
To form that quadratic structure, right? Exactly. So now you have 6x squared plus what? I mean, definitely minus, right? 13x plus 6 equal to what? 0. Now pay attention to something. There are no guarantees that solving by factoring will work. Sometimes it doesn't. That's fine. But we need to try it because that's one of the easiest ways to go about it. If it doesn't work, we go to what? And if it doesn't work, we try what?
Quadratic.
Either one we try. Now in 305 you're a little bit limited because all you learn is solving by what?
Left.
Factoring. So let's hope it does. Let's see. Shall we? Then this is my equation. That's my setup. That's my equation right now. And I'm going to try to solve it by what?
That's the 0 property rule.
By factoring. Let's see. Now comes your knowledge of factoring. Now comes your knowledge of what? Factoring. Let's see who knows what we're talking about. I'm going to go ahead and erase the calculation here for one moment. You don't need it anymore. And I'm going to write the equation. 6x squared minus 13x plus 6 equal to 0. Okay? Well, what strategy should I use here for factoring according to what we have learned? Go for it.
AC method.
The AC what?
Method.
And you see, an 0305 student knows as much as an 0306 when it comes to factoring. 99% is the same thing. It doesn't change. In college algebra, it doesn't change. That's the beauty of mathematics. Well, we don't have a GCF, right? It's obvious. What's my product? What's my product? 6 times what?
6.
Which is 30 what?
6.
And what's my sum? Negative what? Negative what? 13. So essentially we are looking for two numbers, right? The product of those two numbers is what? 36. So I know those two numbers must be either both of them positive or both of them what? Negative. But the sum is what?
Negative.
Negative. So I must be looking at two negative what? Numbers. Well, could you tell me by investigating the product and the sum what those two numbers are?
-9, -4.
You say 9 and what?
4.
But I know you mean what? Negative 9 and negative what? 4. Of course, we can once we kind of get it, we can tweak it to our specification, right? You see, if you choose 9 and 4, it does not work because the sum is what? 13. So what do? You tag a negative to the 9 and a negative to the what? To the 4. Well, that's great. I did get those two numbers. That's what I want, right? Now what? Do I just write the answer x minus 4 and x minus 9? Is that what I do here? I don't think so. What do I do with those two numbers that I just found? What am I going to do with those? Negative 9 and negative 4. I'm going to do what?
Polynomial.
I'm going to expand the quadratic into a 4 what?
Term.
By breaking that middle term, right? So instead of negative 13x, I'm going to write negative 9x, negative 4 what?
X.
Using those two numbers that I just found, right? And what am I going to do with this? I'm going to bring down my what? I'm going to bring down my 6 what? That's going to be 6x squared. And also I need to bring down positive 6 and equal to what?
0.
What have I achieved so far? Now I'm looking at a 4-term strategy, right? Which requires the use of what?
Grouping.
Grouping. Okay, well, let's try to group the first two together. It really doesn't matter which ones you do, right? Which ones you group. Okay, what about this? What's the GCF now?
3.
Between the first two, what's the GCF?
3.
3x.
Uh-huh.
3x.
3x times what? What's left of the first term?
2x.
2x minus?
3.
Minus what?
3.
Okay, so I kind of want 2x minus 3 to be my common what? Factor, right? If I just put over here 2x minus 3, then what does that mean? What did I factor out?
Negative.
How am I going to
2.
get 2x from negative 4x? I factored out negative what?
2.
But I need to make sure still that this one comes out to be what?
6.
What negative times negative is what?
Positive.
And this is also what? 6. So I really do have a common what? Factor. Now what do I do? 2x minus 3 times what? Times what? Equal to what? 0, right? I did factor. So what do I do after I factor? Set each factor equal to what?
0.
And solve, right? And why am I allowed to do that? Because the right side is equal to what? 0. So, let's continue. That means 2x minus 3 as the first factor equal to 0, or 3x minus 2 as the second factor equal to what? 0. Well, what does that mean? X by itself equal to what? 3 over what?
2.
Or x equal to what? 2 over what? 3. What do you notice about those two answers? They are what? Reciprocal, right? You actually have two sets of solutions. What are the two sets of solutions? Well, if x equal to 2 over 3, then the reciprocal will be what? Which is 1 over x, will be what? 3 over what? And if x equal to what? 3/2, then your reciprocal will be what? 1 over x, which is? What is 1 over x in this case? 2 what? Third, which is reflected in the fact that you have two reciprocals as answers, right? Pay attention. Now when you finish, pay attention. You see here that this problem looked simple, right? But when you try it, you see it involves a great deal of what? Of what?
Factoring.
Factor. Now, of course, this problem was chosen by your instructor to show you that factoring is and can be a very, very useful strategy in solving those type of problems. By this time, when somebody asks you what is the strategy to factor, it should not take you more than 5 seconds to decide. If it is taking you longer than 5 seconds, we have problems. You're still struggling with that flow chart. We need to talk. And you need to ask for help. Again, I repeat something. Those of you who struggle with factoring will only come to regret not asking for help. Because you see in college algebra, life is going to get much tougher. Much tougher. Okay. And you see in the examples, for example, if I were you, I would do as homework. If you look at the set of the example that I gave you, you can try for your as practice. You can try number 1, number 2. Number 3, those are number 1 and 2 and 3 are number problems. For example, let me just help you set up number 2 for the problem in page 5. Let me just help you set up number 2 in page 5. Shall I erase this? Everybody wrote it down? Okay. Of course, what we're going to do, once you send me the video file, I'm going to post that also on Blackboard. So the people who missed the lecture can still try to benefit a little bit. Okay?
Dale record.
That's okay. Anything else bothering you? All right. Somebody read to me number, which one we said we're going to set up?
2.
Okay. And what does it say?
Find the numbers such that the square of the sum of the number is 3 and is.
So first we write the statement and we try to translate. You see, can you do those problems if you don't know how to translate from English to algebra? The answer is a definite no. You can't. You just can't. The sum of what? Oh, the square. The square of the what?
The sum of
The square of the sum
3 is 100.
of the number and 3 is what? 100. Now, this is interesting because we have 0305 student and 0306. First, I'll show it as if we were trying to teach 0306. And then I'll try to show it as if we are trying to teach 0305. And you'll see it kind of gets interesting. But first of all, we need, how do we translate the sum of the number and 3? We don't know that number, do we? So let's call it what?
X.
X. The sum is x plus what? X plus what?
The
Plus
sum
3,
of the
right?
number
But he doesn't want the
is
sum. What does he want?
And 3.
The square of the what? So we need to raise all that sum to what power? If we're talking about the square, we need to raise it to what power? To the what power? Equal to what? Equal to what?
100.
Equal to 100. Now, I'm hoping that somebody from my 0306 is going to tell me what to do now. Since I have the left side as a perfect square, what can I do? Apply what to both sides? Apply what?
Chicken's carriage.
Yes. I can apply what? Square root, right? To both sides. Now let's see who still remember. Well, what is the square root of something square?
So, absolutely.
You see, this is beautiful what you said. She remembered, she was here on Saturday. X plus 3 absolute value equal to what? What is the square root of 100? 10. And when it comes to absolute value, we always have two answers for the input, right? Unless we're talking about 0, then that doesn't matter. So what is the input here? X plus 3 can be equal to what? 10. Or x plus 3 can be equal to negative what? Which leads to saying x can be 7, Or x can be what? Negative what? Negative what?
13.
13. So, we have two possibilities, right? Pay attention. Sometimes there's a frenzy about trying to check for your answer, right? Now pay attention. Checking if your answer is correct or not is a good mathematical skill. But it doesn't mean every time you have a problem you have to go back and check your what? Answer. Sometimes it's useful. Hey, let's go check the answers. You see what happened. It says that the number, one of the possibilities that the number is what? 7, right? Well, let's see if that's going to work. Well, 7 plus 3 is what? 7 plus 3 is what?
10.
And 10 squared is what?
100.
Is what?
100.
Looks like 7 is working, right?
Yeah.
And then he said one of the number also is what? Negative what? Let's see if it works. Well, negative 13 plus 3 is what? Negative what? Negative what?
10.
And what happened when you square negative 10? The answer is also what? 100. Now pay attention. If you're an 03 or 06 student, you knew that this could be solved by taking the square root on both sides, right? Because you knew that the left side is a perfect what?
Square.
Square. Well, what happened if you're an 03 or 05 and you're like, well, that's not fair. You didn't teach me this stuff. And that's okay. I'm going to teach you. I'm going to show you what to do. First of all, copy all this. You did this by taking the square root on both sides because the left side was a perfect what?
Square.
Was a perfect what?
Square.
Was a perfect what?
Square.
That's right. I'm going to give you 1 minute, then I'm going to do the same problem as if we were talking about 03, 05 strategy. Okay? And you see all those strategies that you have been learning, completing the square, solving using the quadratic formula, which is going to come in about 2 to 3 problems. Those are essential strategies. You cannot do problem solving for this chapter if you don't know completing the square and the quadratic formula and the factoring strategies, all of them together. Okay. Sounds good. Don't y'all love coming here on Saturday doing this? I mean, it's nice, isn't it? Well, maybe we don't. Yeah. But just because we have a camera, that doesn't mean I change who I am, right? I'm still gonna be crazy. I'm still gonna scream. But I'm still gonna teach you a lot of what. That's right. Now imagine, Carly, that this problem was given to you. And when I say Carly, I mean all of you. I just know her name. That's the problem. And that was the problem. X plus 3 squared equal to 100. Right? But 03, 05, probably you don't know completing the square. You don't need to. Pay attention to what we're going to do. This is x plus 3 multiplying itself how many times?
2.
2 times. Let's do multiplication. What is x plus 3 times x plus 3? Equal to what? What's x times x?
X squared.
And then plus what?
3x.
And then plus what?
3x.
And then plus what? 9. And then I'm going to take that 100 over here because negative 100 equal to what? 0. And let me go ahead and combine like terms, right? So what happened when I combine like terms? I see x squared. What is 3x and 3x? 6 what? And what is 9 minus 100? Negative what? Huh? Negative 90 what? Equal to what? 0. Okay? All right. What is my sum? My sum's got to be what? And what's my product? Negative 91. Can you tell me what those numbers are? I think you come up with, if I'm not mistaken, 13 and negative 7. Because if you try to multiply 3 times 7 is 21, right? 1 and 2. And 1 times 7 is 7, and 2 will be 9, 91, right? And also 13 minus 7 will be what? 6. So you see here, this comes out to be x plus 13 times what? X minus 7 equal to 0, which means from the first one you're going to get negative 13, and from the second one you're going to get positive what?
7.
Isn't that the same answer we got from before? Remember, there is no one way to deal with this problem, right? But of course, if you're in 0306, you'll find it much more efficient to just apply the square root on both what? Especially because you guarantee that the left side is an actual perfect what? Perfect square. Okay. I just wanted to show that that problem could be done in 0305 or 0306. Let me give you the handout that you're going to need for your life. This handout might save your life one day, who knows? It contains a lot of emergency. Okay, shall we erase all this now? Not really, right? Next semester, what I'm going to try to do is put all the lectures on YouTube. On your 306 or 305 college or whatever. It doesn't matter. Then we become celebrity. On TV. I would. As long as we learn math, that's the only thing I care about. Isn't that right, Carly? I mean, all of it. Shall we erase the whole thing now? So we are done, you and I, talking about number what? Problems, right? Find the numbers, right? You see on the exam, on the second exam, if you're an 0306 student, I probably included 1 or 2 problems like this. Finding the what? Numbers. But now you should be very familiar with this. Shall we erase all this now? Yes? No? Maybe? Okay. What is the Pythagorean theorem? What does it say? That if you have what? Well, let me ask you a more specific question. Does the Pythagorean theorem apply to any triangle or only the right triangle?
Right triangle.
So what does it say? Let's say we have a right triangle, okay? First of all, the sides that are tangent to the 90-degree, what do we call them? Those are the what? Those are the what? Those are the what? The legs. And what about the longest side? What do we call it? The hypotenuse, right? Let's say A, B, and then what? C. This is the what? Hypotenuse. The Pythagorean theorem states that the sum of the squares of the legs is equal the square of the hypotenuse. Meaning, first of all, A squared plus what? Equal to what? C what? Square. And of course, the Pythagorean theorem has a converse, which means some logical way to say it backward, using this as a starting point. What do we mean? Well, if we have a right triangle that has legs A and B and C as measurements, then we can say A squared plus B squared equal to what? C squared. The converse of this is that when we have A and B and C, such as A squared plus B squared equals C squared, then you will know we are talking about a right what? Triangle. And one of the fundamental ones, numbers like 3, 4, and 5. 3 squared plus 4 squared is 5 squared. You can try it. 3, 4, and 5 is a classical example of what? Of a right triangle. Let's see if we're right first. What is 3 squared? And what is 4 squared? 9 plus 16 is what?
25.
And definitely you agree that 25 is actually 5 what? Squared. Just for your information, to review something you should know already. 3 and 4 and 5 together are called what? A Pythagorean what? Pythagorean what? Triple. Which means together as they form the right what? Triangle. Okay? This is basic geometry review. If you need a handout about all the geometry review, just send me an email. I'll send you one. It's about 51 pages, but you will enjoy it. You can also download it and put it on Facebook. So all your friends. And update your status on Twitter. From doing second exam to reviewing geometry. Exciting. And then you can put something exciting in the update, like I went and got a Diet Coke and see how many followers you get. Since that seems to be like very important. Okay. I know it's an earth-shattering event. It's very important to know exactly what time you actually got it and what process and everything. Definitely. Okay. Let's see how geometry is involved in factoring. First, we start with a classical example. For example, let's talk about example number 2. So what does he say in example number 2? What does it? He's asking us to do what? He's asking us to do what in example number 2?
Find the other leg.
Hypotenuse of one leg of a right triangle is what? 10 centimeters, right? Pay attention to something. What is a good strategy always to solve a geometry problem? On top of choosing the variable, setting up your equation, which is to do what? To actually kind of try to do what? Draw a what? A picture. Draw a diagram. Label your side. Know what you're talking about. So definitely in this example, example number 2, I'm talking about a right what?
Yeah.
Triangle. Well, this is a right triangle. I don't know. Maybe that's what. This look good. Right triangle. He said the hypotenuse and one leg are 10 centimeters. And what? 8 centimeters. Right? So of course the hypotenuse will be what? 10 centimeters. And this will be 8 what? Centimeters. And then what is he asking you to do? Find the other what? Leg. Well, let's call this shift what? X. Maybe before we put that video on YouTube, we should clarify the meaning of shift, right? Oh, we shouldn't. That's not important. Pay attention. What's the equation that we're going to be using here? How are we going to set up our equation? Using the Pythagorean what? Exactly. Which states what? X squared plus what? Plus 8 what? Equals to 10 what? Now please, before you try to do any calculation, finish one thing at a time. One step at a what? So what does that mean? X squared plus, what is 8 squared? 16, right?
64.
Somebody said 16. Only me. 64. And what is 10 squared? Are you sure it's not 20? Yeah, you are. So now what's going to happen is, I need to isolate that x squared, right? And how am I going to do that? Transpose the what? X squared equal to 100 minus what? 64, which is? Huh?
36.
Sure. 36. So if you apply a square root on both sides, what's going to happen now? Are you sure x? Or absolute value? Well, I mean, you're going to end up disregarding the negative, but we have to say it. What I mean is, this tells you that absolute value of x equal to what? 6. Which means x equals 6, and x equals negative what? 6. But of course, which value we should reject? Which value we must not accept? Remember, this is when checking the answer becomes a question of Are we being reasonable or not? Can we have a distance that is negative 6 something? I don't think so. Also, like you find in the age of Maria, Maria turns out to be negative 15 years old. We have a lot of problems. Be careful, we must discard of this. It's not good answer. So what do we say? This is simply, we say rejected, right? So what's the only acceptable answer? X equal to what? Because you know distance is always a positive measurement, right? Okay. Be careful. Now, this is a classical example about a Pythagorean theorem. Things can get very complicated, and they will. But still, we have to use what? Our fundamental knowledge of geometry and a little bit of the setup. Okay. You really don't have to write that question. I just wanted to show you some of them. For example, before we move on to the area, I want to try to ask you to set up one problem together, you and I. If you turn to page, please, if you turn to page 5. And he asks you, I'm going to ask you to set up number 5. See if you can set up number 5. Let's write down what number 5 states anyway. What is number 5? See if you can set it up. See if you can set up number what? Okay, number what? Number 5. Find the length of the side of the square. So we're talking about a what? We're talking about what kind of quadrilateral? About a square, right? And we need to find the length. Where's the problem? Number 5. Find the length of the side of the square. Let's call it x, right? Let x equal the side of the what? Of the square. But the diagonal is what? He said the diagonal is what? Is actually what? 12 inches. Again, what do we do when we have a geometry problem? Try to draw some picture, right? Try to actually depict some kind of a diagram. You see, what is he asking you to do? Well, this is a square. You know in a square all the sides are congruent, and also all the angles are what? Congruent. You see, we don't say equal because equality is only between two numbers. Congruent. If you and I have the same height, hopefully not the same weight, way about that, maybe about this. And that doesn't mean we are equal, right? We share a measurable what? Height together. He said that diagonal is what? Diagonal is what? 12. Okay? This is the diagonal. And he wants you to find the side, right? But let me ask you a question. If this is x, this is going to be also what? X. And what can I do within this triangle? I can apply what property to find x? The Pythagorean what? How do I do that? Well, x squared plus x squared equal to what?
12 squared.
12 what? Squared. So what does that mean? You see, pay attention to something. You see why word problems are always challenging, right? Because they don't depend on you knowing one simple fact. You kind of want to know a lot to be able to set up a word problem, right? What is x squared plus x squared? Huh? That's right. Equal to, what is 12 squared? 100 and what? 44. So how do you isolate x squared now? What are you going to do with that 2?
Divide all terms.
Divided by what? By 144, right? So now what do you have? X squared equal to what? 70 what? 70 what? 70 what? 70 what?
2.
That's right. So now I'm ready to do what? To apply the square root. Of course, here also, you see you're gonna have a positive value and a negative what? Which one you must accept only? We can't have distance that's negative, right? So x by itself equal the square root of 72. If you know 306, and all of you, we talked about this. What is gonna happen when you have the radical? Must you leave it like this or must you simplify? If you can, right? Well, can you simplify that square root of 72? What combination do I use of numbers that will allow me to simplify? 8 and what? Yeah, that's right. Well, why did you choose that? Well, pay attention. What about the square root of 9 is what? 3. So that will be 3 square root of 8. Can I simplify some more? Or do I stop?
Yes.
You think I can, right? What about the square root of 8? What can I simplify it at? Square root of 4 and what? What is the square root of 4? So what's my final answer? 3 times 2, which is? And then inside the radical, which is square root of what? 2. Actually, x is equal to 6 square root of what? 2. Pay attention to something. Notice one thing. What is the value of the diagonal? Huh? What is half of 12? It's always a law. Half, and then you multiply by square root of what? 2. Later we can tell you. We can talk about it if you like. This is called a special right triangle because here we have 45 degrees, and also here we have 45 what? Degrees. If this is x, this is x, this is going to be x square root of 2. Okay? What do you notice we are doing here? We are mixing geometry with what? With algebra, right? You know what this is called in mathematics? Analytical geometry.